if you remember, we need to figure out something called degree of freedom, or how many unknowns do you have? Actually, for beans, we are looking for theta as unknown. Your unknowns in beans, theta, probably if we are talking about frame, probably we may have delta. But for beans, we are talking about theta. So I'm looking for theta at A, theta at B, theta at C. Because A is fixed, I can say theta A is 0. Because C is fixed, I can say theta C is 0. Because B is not a fixed support, it's a roller. I cannot say theta B is 0, but it's unknown. So first step, just where are your supports? We have theta at each support. If your support is fixed, theta equals 0. If your support is not fixed, theta is unknown. Second step, we are looking for something called fixed end moment. We are looking for something called fixed end moment. You are going to assume each member is fixed from this end and fixed from the other end. And you have concentrated load, how much? 6 kip. This member called AB. The other member will be assumed fixed with uniform distributed load. How much? 0.5 kib per foot, and this member called BC. If you go back to the cases of fixed end moment, we have this case and we have this case. So your fixed end moment values will be, this one will be like this, and this one will be like this. Your values, this distance is 8, and this distance is 8. So your value will be 6 times 8 square times 8 divide 16 square. 6 times 8 square times 8 divide equal 12. So this value will be 12, and this one will be 12 also. That means I can say M fixed AB equal negative 12, M fixed BA equal positive 12. If you remember, we have something called sign convention. If your moment clockwise will be positive, if your moment in counterclockwise will be negative. If you are talking about M fixed AB, I'm talking about this side. If you are talking about M fixed BA, I'm talking about this side. One more time. If you have member fixed with uniform distributed load, I believe your fixed end moment here will be like this and like this, W L square divide 12. So your value 0.5 W, L, the whole distance is 18, square divide 12. So 0.5 times 18 square divide 12 equal 13.5, 13.5. So your fixed end moment, M fixed. MF means M fixed end moment. You assumed your member fixed. BC, I mean this side, will be negative 13.5. M fixed CB will be positive 13.5. Any questions so far? Any questions so far? We covered all of this stuff last time, and the two first steps, very easy. And the next steps also will be more easy, don't worry. Okay, step number 3. We need to apply something called slop deflection equations. This method is called the slop deflection equation. So we need to apply slop deflection equation. We have here 2 equations for each member. This equation and this equation. So I would like to rewrite it in a good shape. I will write it like this: MAB, which is the final moment, equal M fixed AB plus 2 EI divide L time 2 theta A plus theta B. If you are looking for MBA, I'm talking about one member, AB. So if you are looking for final moment at this side, here is the final moment. If you are looking for final moment at this side, your final moment at B will be MBA plus equal, I'm sorry, M fixed BA plus 2 EI divide L time 2 theta for the first point B plus theta A. So it's 2 times theta for the first point plus theta for the second point. This term is neglected. It's neglected because we don't have delta. It can be used in frame, more complicated frame. But we are talking about beam. You have only one unknown, or unknowns only theta. So this term can be neglected. So let's do it. If you are looking for MAB, which is the final moment for member AB, that means you are talking about this point. Your final moment will be M fixed AB plus 2 EI divide L time what? 2 theta A plus theta B. Go ahead and put your numbers. Yeah, I can put numbers because M fixed AB equal -12. L for this member AB is 16. Theta A 0 because A was fixed. Theta B is unknown. So your final equation will be -12 plus 2 EI divide 16 times theta B. One more time. I'm looking for MBA. We're still on this member, AB, but I'm talking about this side. MBA will be M fixed BA plus 2 EI divide L time 2 theta for the first point, B, plus theta for the second point, A. Go ahead and put your number. M fixed, BA, positive 12. The length of this member, AB, 16. Theta B is unknown. Theta A was 0 because it's fixed. So your final equation will be positive 12 plus 2 EI divide 16 times 2 theta B. Keep going because we still have another member BC. If you are talking about this side of this member, so M final BC equal M fixed BC plus 2 EI divide L time 2 theta for the first point B plus theta C. Put your number. M fixed BC, I believe you got it before. Negative 13.5. L, the length of this member, how long? 18 feet. Theta B is unknown. Theta C, it's 0 because point C is fixed. The final shape of this moment, of this equation, will be negative 13.5 plus 2 EI divide 18 times 2 theta B. For the same member BC, we need to talk about this side, which called MCB. So finally, MCB will be M fixed CB plus 2 EI divide L time 2 theta for the first point, theta C, plus theta for the second point, B. Put your number. M fixed CB is positive 13.5. L is 18. Theta C is 0. Theta B is unknown. So the final shape of this equation will be 13.5 plus 2 EI divide 18 times theta B. Do you think we still have any members or any side? We have 2 members. Each member has 2 sides. Each member has 2 sides. So we have 4 equations. MAB, MBA, MBC, and MCB. For this step, any questions so far? Please let me know. It's a piece of cake. It's very easy. You know, structure analysis after the first 4 chapters is nothing. Probably after influence line. Just steps. Steps you need to follow. That's it. Any questions so far? Okay. Last step. Step number 4. Apply equilibrium equation. We have the original beam looks like this. Fixed here, roller here, fixed here. This one is A, this one is B, this one is C. Actually, we have MAB, you are talking about this side. MBA, you are talking about this side. MBC, you are talking about this side. MCB, you are talking about this side. theta at A 0, theta at B is unknown, theta at C is 0. I will give you a hint. Please search for equilibrium equation where theta is unknown. It's a hint for yourself. Please search for equilibrium equation where theta is unknown. So let me ask you a question. Where theta is unknown? At A? No. At C? No. At B? Yes. So your equilibrium equation will be here. Any moment at this point, summation of any moment at this point equals 0. That means MBA plus MBC equals 0. Here is the equilibrium equation. Any moment at any support equals 0 if your theta at this support is unknown. So one more thing. Please search for equilibrium equation where theta is unknown. I cannot say MAB equals 0 because theta equals 0. I cannot. At C, I cannot, but B, theta is unknown, so my equilibrium equation will be here. And it doesn't make any sense to say MAB equals 0 because we don't have anything on the other side. At C, we don't have anything on the other side. So I'm trying to help you. If you would like to get the equilibrium equation in a very, very, very fast way, go ahead directly to the support with theta is unknown, summation moment at this support equals 0 from this side plus this side equals 0. Yes. So I will say, hey, be careful. MBA and MBC, you already have them. MBA, you have this equation. MBC, you already have this equation. Go ahead and sum. Make summation for this equation plus this equation equals 0. So, I will say MBA. What was MBA? Positive 12 plus 2 EI divide 16 times 2 theta B. This term or this equation is MBA plus MBC. What was the equation for MBC? Negative 13.5 plus 2 EI divide 18 times 2 theta B. Summation of these two moments equals 0. If you look back to this equation, you can find that we have only one unknown, theta B, which is the only unknown in this problem. Okay, go ahead and solve. We can solve. Positive 12 minus 13.5 is negative 1.5. This term, 2EI divide 16 times 2, 2EI divide 18 times 2, theta B, finally will be something like this. I will tell you 4 divided 18 plus 4 divided 18 will be 17 EI divide 36 theta B equals 0. I just added this term after I did the multiplication. 2 divide 18 EI theta B plus 2 times 2 divide 16 EI theta B I got this term. So put theta b on one side, it will be 17 EI divide 66 on one side, and everything on the other side will be positive 1.5. Finally, I can say theta b will be 54 divide 17 EI. EI should be given, but we don't care because it will be cancelled each other. EI should be section properties. E Young's modulus based on the material, I moment of inertia. We don't care. I just put this term on the other side. If you move this term on the other side, the numerator will be denominator and the denominator will be numerator. Be careful. And I got this final answer. Then go back to this equation. MAB, which equal negative 12 plus 2EI divide 16 times theta B. At this moment, I know theta B. Go ahead and put the value of theta B. So your final answer for MAB will be negative 12 plus 2EI divide 16 time theta B, which is 54 divide 17 EI. That's right. It's negative 12 plus 2 EI divide 16 times theta B. I put theta B with this value. I think I can cancel EI by EI. So I think I can get a final answer. Your final answer will be negative 11.6. Keep going. Keep going. MBA equal. Go back to this equation. Positive 12 plus 2EI divide 16 times 2 theta B. And don't forget to put the value of theta B. So positive 12 plus 2EI divide 16 times 2 theta B, 54 divide 17 EI. I think EI and the EI will cancel each other. Your final answer will be negative 11.2. Keep walking. We still have two more. MBC, which is negative, positive, negative, positive, I cannot remember. Negative 13.5 plus 2 EI divide 18 times 2 theta B. EI will cancel EI. I can get a final answer. I'm sorry. I think we have a mistake here. Probably here. Not sure. Let me try it one more time. Yeah, this one should be positive 12.8. MCB, I'm sorry, I got this value in a wrong way. MCB will be, if you remember, MCB, positive, okay. Positive 13.5 plus 2 EI divide 18 times theta beam. I can get a final answer. 2, 18 plus 13.5, 13.85. Check. F MBA plus MBC equals 0, you are right. Don't forget that your equilibrium equation at B, MBA plus MBC equals 0. It is your equilibrium equation. To be sure you are doing good, what is the value of MBA? What is the value of MBC? If you add this number plus this number, you can get 0. We are good. We are good. So finally, your beam, which looks like this, value of moment here is negative 11.6. Value of moment here is positive, if you are talking about this side, positive 12.8, this side negative 12.8. For this moment, it's 13.85 positive. Yeah. So what should I do? What should I do? Where is the bending moment diagram? Okay, I can tell you what you should do. This member and this member. Guys, I told you that this value is positive. Positive means clockwise. This value is negative. Negative means counterclockwise. This member, your value here is negative, counterclockwise. This value here is positive, clockwise. So your value here is 13.85, 12.8, 12.8, 11.6. If you would like to draw your bending moment diagram for the beam, here is the beam. Just a second, I'm sorry. Yeah, my surface is stuck, so just 1 minute. Sorry, guys. So your final moment for this point, I'm going to follow this head. It will be down 13.85. For this one, I will follow this head. So it will be down 12.8. I'm going to follow this head also. It will be 11.6. Between this value and this value, I will draw a dashed line. Originally, we have concentrated load. So I'm going to hang this triangle. Between on this member, we have distributed load. So I will connect by dashed line and I will hang a parabola. I think you know this information. Do you remember for conjugate beam method? If you have simply supported beam with one concentrated load, if you have simply supported beam with uniform distributed load. Do you remember something like this? This concentrated load, your moment will be triangle. Distributed load, your moment looks like parabola. So between this value and this value, I will draw a dotted line. On this dotted line, go ahead and hang this triangle. Between this value and this value, I will draw a dotted line. On this dotted line, go ahead and hang the parabola. Here is your bending moment diagram for this beam. Actually, I will give you the full credit until this step. You need only to give me the final values for MAB, MBA, MBC, and MCB. Once you are done, you will get the full credit. You don't need to go through these steps, but if you did and draw this final shape, I will give you extra 3 points. Fair? Any question? One more example because we don't have enough time. One more example. We have another example here. Member beam ABC. A is fixed, B is roller, C is fixed. We have concentrated load, we have triangle load. We don't care. Let's do our steps. First step, degree of freedom. Degree of freedom. We have theta at A, we have theta at B, we have theta at C. Theta at A is 0 because it's fixed. Theta at B is unknown because it's roller. I don't know. Theta at C is 0 because it's fixed. Second step, fixed end moment. I'm going to assume this member fixed with this triangle. This member is AB. I'm going to assume this member fixed, concentrated load 80 kilonewton. This member called BC. I think we have a case for triangle. If you go back for this case, you will find here WL squared divide 30. This one will be WL squared divide 20. this value and this value. So finally, you can find M fixed AB, M fixed BA, M fixed BC, M fixed CB. I will give you these values. 20 time divide 30. This value will be negative 54. 20 time. This one will be a positive 81. This one will be negative 60. This one will be positive 60. Okay. Third step. Piece of cake. Third step. Apply Slop Deflection equation. Apply Slop Deflection equation. We have member AB, so we have MAB, MBA. We have member BC, so we have MBC, MCB. So I will have MAB, I will have MBA, I will have MBC, and MCB. Go ahead. MAB بتساوي M fixed AB negative 54 plus 2EI divide the length of this member 9. I think this length is 9. Yes. Time 2 first theta A plus theta B. I think theta A is 0. So the final shape of this equation will be negative 54 plus 2EI divide 9 time theta B. The same steps. Everything's the same. MBA will be M fixed BA positive 81 plus 2EI divide 9 time first theta 2 theta B plus theta A. I think theta is 0. So the final shape of this equation will be 81 plus 2EI divide 9 time 2 theta B. Keep going. MBC will be M fixed BC, which is negative 60, plus 2EI divide length of this member 6 meter, 2 theta B plus theta C. Theta C is 0 because it's fixed. So the final shape of this equation will be negative 60 plus 2EI divide 9 time 2 theta B. Finally, MCB will be M fixed CB, which is positive 60 plus 2EI divide 6 time 2 theta C plus theta B. The final shape of this equation will be positive 60 plus 2EI divide 6 time with theta C is 0 plus theta B. Anybody can tell me what is the equilibrium equation? If you would like, your beam looks like this. Here is A, B, C. We have MAB. At this side, we have MBA. At this side, we have MBC. At this side, we have MCB. Theta A is 0. Theta B is unknown. Theta C is 0. So where is your equilibrium equation? At A or B or C? What do you think? I think your equilibrium equation will be at B. So MBA plus MBC equal 0. Here is the equation for MPA. You have this one. And here is the equation for MPC. You have this equation. Add them together, you can find that theta B is the only unknown, so I can figure out the value of theta B. Once you get the values of theta B, go back, put theta B, theta B, theta B, and theta B. You can get the final answer for MAB, MBA, MBC, and MCD. To check your answer, this value and this value must be the same, but with different sign. One of them will be positive and the other one will be negative. Once you get your values, you are done. If you would like to get extra points, put this value up or down, this value up or down, this value up or down, and dotted line, we have a parabola. Because it's a distributed load. Dotted line and put a triangle. Because we have concentrated load. This shape can be called final bending moment diagram. Yes, yes. If you go back to the conjugate beam diagram, Oliver, you can get the shapes, triangle or parabola or something like this. Okay. So be sure that the final score or the full credit will be given if you give me the whole values for MAB, MBA, MBC, MCB. If you would like to put these values, which one, the one is positive, it's clockwise. The one is negative, is counterclockwise. Then you need to follow this head. The head is down, your value is down. The head is up, your value will be up. Once you put your values up or down, connect between both of them by dotted and hang the shape that you have here. Here we have concentrated load, so we have triangle. Here we have distributed load, so we have parabola. Once you did this, here is your final bending moment diagram. If you did this shape and this shape, I can give you extra 3 points in the exam.